Hi, in this episode we're going to look at how to handle motion on your MMO server using Unreal Engine. All of the steps on how to reproduce this are on this blog post and the link will be available in the description. It goes into step by step how to get this done, including creating your C++ classes, how to integrate them with your Unreal project, and how to integrate them with your blueprints. So it's quite in depth, so if you want to follow along, do check this out. The server code that I'm using will be available in this GitHub repository, so feel free to check that out. Do note that this is more for educational purposes, so if you want to learn along, how does this work, etc., this is great. But if you do want to use this more in production, have a look at what's sort of already out there, because there's quite a lot of content. So for instance, Saber Art Studios, they've created an AWS. This is an open source platform. This is an open source server effectively. It's based on C#, so that's partially why I'm not using it. I want to sort of learn a bit more Java and learn more about MMOs, so I'm doing that. But this is certainly much more fleshed out. And also, this particular video is sort of highly inspired from this one. So this is where Saber Dart Studio shows how to do motion using C#. So follows a very similar topology, but just a different language effectively. So do check that out if you're interested in the C# versions, for instance. And also, if you're looking more of a MMO build tools, there's other things available. So for instance, I'm personally waiting for these guys. Hopefully they're going to be finished this year. I'm not 100% sure. I think they were supposed to be finished already, but they hit some setbacks and they're delaying by quite a bit now. So we'll see how that goes. But Atavism, I've seen that they've got some tools for Unity. So if you're tool agnostic, maybe you want to start a Unity project, check it out. But I'm personally waiting for the Unreal one, so we'll see how that goes. And there's other tools as well, right? So if you want more production stuff, there are already tools out there. If you want to sort of learn how does it all work, in the networking world, then do follow this along. And yeah, let's first show you what it is that we're building, so you can see whether this is something you want to follow along. And let's go from there. So you might be familiar with the screen. So this is the character selection screen that we've left off in the previous video. And we're now able to click login and go to this world, right? So I'll just position this guy like this so we can see a bit more. And I'm going to now log in with my second character. Let's just run around here. So you can see, let's just position this guy here. We'll move this a bit more. So we can see that we're synchronizing the motion between the two clients effectively, right? And this is not using any Unreal Engine networking. This is all using the dedicated server. And yeah, we can move around, we can jump, we can do some stuff. You can see it's a bit jittery. I mean, the first reason is because it's in two different windows, right? It's trying to reduce some load, but also, it certainly can be improved. So you can reduce or rather increase how many times per second you update the server information, so you get faster responses on your client. And you can also make the smoothing a bit better on the client as well, right? Because it's very basic right now. So yeah, if that's what you're interested in doing, let's have a look at how to sort of get this up and running. So I'll first get started with the character selection widget. So this is where we select our character and we click the login button, right? So we've got the unclicked button login. All we need to effectively do is set the character that we're playing with effectively, right? We store it to the game instance settings. The game instance is effectively your global variables repository. And then we'll open the level, right? So we open up the starter level and we load in our character. So I'll quickly show you the game instance, right? So this might have changed. I think we were just passing appearance info. Now we pass in the entire character base, which also includes the appearance info. So effectively making this redundant. I can delete that, but that's fine. I can do that a bit later. So now that we've effectively loaded our character into the game world, we want to synchronize it with a server. So how do we do that? We can have a look at this stylized third-person blueprint. So I've showed how to get this up and running in the previous episode. And what we need to do is effectively connect it with the server. So how do we do that? First of all, we link it with the parent class. So the parent class is the C++ class that we're basically creating, right? So we've got connected character.header, connected character.c++, and this contains a couple of functions for us to use. So just make sure that you've parented this class, and what we do is we provide it an access token. So this allows us to communicate with our backend. The access token authenticates our character. It basically says, this is like my user, so I want to update this stuff, right? So the account character base, for instance, will have information about my character name. So the access token will give you your user, account character base will give you your character, and then what we want to do is we set a timer. So here we say every 50 milliseconds update the player location. So we call this update location on server function. So this is a C++ function. And I'll go from a little bit of a high level to basically say this is sort of what needs to happen on a client to server basis. And so this is the response. So yeah, this is what we're sending effectively to the server. So what happens is that we send an API call to our server and we say, okay, this is the player name, and what we want to do is we want to update the motion of this player. So we do this every 50 milliseconds effectively. We say update the X coordinate, Y coordinate, Z coordinate. This is essentially our location. We also want to update the rotation information as well as the velocity, right? So this way we sort of synchronize the entire motion of the character that you're playing with, right? And what this enables us to do is then display this information to any other characters that are around you, right? So I'm saying update the location on the server, and as a response, I'm going to receive information about other characters that are around me, right? And this has to be coded in your backend effectively, right? I'll very quickly show you. So we've got the player motion service. We say update the player and get the players near me. This response is going to have a list of characters, and that list is going to have things like appearance information, motion, obviously it's got to be online as well. Okay, so we receive this list of information, and then what we have to determine is this a new character, or are we just updating an existing character that we've already pre-rendered, right? If it's a new character, we have to create a new object on the screen, and if it's an existing one, we just simply update that object, right? And then we send these updates to the blueprints, right? So if I go in here, we've created a new little graph here, so to handle them, just to keep things separated. And then we have it, right? Event notify new character. So this event is fired after we update the location for our character, right? And here it is, update notify new character. Notify new character. So we receive this response, right? Proxy character. And what this includes is things like the character base, right? So it's got things like the name, experience, account name, appearance info is actually what we care about, and other information like the velocity, location, rotation, right? So the new character is going to be added into a list of nearby characters, right? So we're going to use this list to generate, or rather spawn, objects. I'm going to show you how to create this proxy character shortly, but we basically keep a list of characters that are around our main character, right? And we're going to effectively update all the information from those characters. So we spawn the actor, proxy character, we attach the location and rotation to that character, we also set the velocity of that character, and we modify the appearance information, right? So we get the account character base, we grab the appearance info, we set it inside the proxy character, we sync the appearance info and update mesh. I think perhaps, yeah, we've already created the sync appearance info in one of the previous episode. I think maybe I've just created the, oops, got lost now. Update mesh, let's have a look. So, okay, yeah, we've created this in the previous video as well. So this simply updates the mesh. It goes through object by object and just updates it, making sure that the mesh is exactly what the variable tells it to be, right? Because that wasn't automated in the past. Okay, so that's what happens when we update the character, okay? Or rather, when we create a new character. And then on event notify update character, what we do is we look through a list of characters. I'll just show you this variable, right? Nearby characters, and all it is a map of strings, right? Or rather, like, this might be even just a list, right? Okay, so it is a map, and the key is your character name, and the content, the value, is the proxy character, right? So we basically just have a map of all of these proxy characters which are around our character, and then we update their information, right? So there's our nearby characters. Here we have the notify update character. What we do is we have a look to find this player name in the characters that we already have. Once we found him, we update the character movement and we effectively set the information. So we update the location and rotation. We set the velocity from the proxy character base. And yeah, we also set is falling. This, by the way, is not fully enough to synchronize the falling, but all the other motions, it will automatically handle it. So one other thing that we could probably do, which we haven't done here, is extract the character base and then synchronize the appearance information as well. But seeing that we're not actually updating the appearance information once we're in the game yet, it's a bit redundant. Like, it's not going to effectively change anything. But you can see where this is going, right? Effectively, you spawn the character using this piece of code. It could probably be refactored as well a little bit. And then every 50 milliseconds, we're going to be updating some information, and we're effectively going to be updating the location, rotation, and velocity. Ideally, this would have been updated here as well, but it does get updated separately. Okay, so that is our stylized third-person character, right? There wasn't any other additions that needed to be made here, like not into the main blueprint. Just the fact that we're basically calling this update location on server, and the bulk of the work is actually done on your C++ code, right? So it's not really visible too much in your blueprints. It's handled in the back. Now, what exactly is the proxy character? So the proxy character is effectively the same object as your main character. So it's effectively a clone of your character, but it represents other people, right? So one way to do it is to effectively copy your stylized third-person blueprint and call it proxy character. There's only one big difference, and that is that we don't have any of these motion blueprints, right? So this is like your movement input, jump, mouse input, all of this stuff. So we don't need it because the motions are actually controlled via the server, so we don't need to be updating, well, we don't need this piece of code effectively, right? But there is one thing certainly that we've added is add some smoothness to it. So you saw in the connected code that we're updating the location, rotation, and velocity, right? So one way to smooth things out a little bit is to actually apply the velocity into the position, right? So we update every 50 milliseconds, but your frame rate could be faster, obviously. So we want to be updating the position of this object, right? So we have this event tick, and we have the delta seconds, and we have the velocity. So using the velocity multiplied by the time, we get some position that was moved effectively, right? So what we do is we get the actor location, and we add the position that was moved, and then we attach it to the new location, right? So it's very basic smoothing. And yeah, certainly it can be improved, but it does a basic job, right? And I think that's actually it. That's effectively the only changes that were required here. And bear in mind, the proxy character does not need to be connected like this one. So you can see I've added here set local access token. I've showed this a few minutes earlier. We don't need that piece of code here because this doesn't need to be calling any updates, right? This is the main character that we're playing, so we want to update our server with this information, and the proxy character is basically just a dummy pawn character which just absorbs all information and tries to display it on the screen, right? Okay, so I also mentioned that the falling was not basically handled automatically, right? So let me just show you what happens. Inside our animation class, I basically didn't create a separate animation for the two characters because obviously they're stemming from the same thing. So we want to keep things as much possible together as we can, right? But the falling is in air field. I cannot be setting that inherently. It's a bit weird. So, for example, there's for your standard blueprint, we're evaluating if the target is falling. So this doesn't get inherently evaluated for a pawn character. So what I needed to do is effectively take the animation blueprint, I get the object, and I say, is the object owner a proxy character or not? So is it my main character or is it a proxy character? If it is a proxy character, then what I'm going to do is take in this is falling variable that I set. I believe I set it inside the connected, right? So you can see it's here, right? It's falling. I set a local variable, I think. There it is. So I created a new variable here, is falling. And I set this variable is in air. And that's how the animation will start rendering the falling animation, right? So that's how you effectively synchronize those animations. So occasionally things will be extracted directly from your information, like basically all your local variables here. But sometimes you might need some manual interventions, like this one, for instance. And that's how you would do it, essentially, right? Just locate the field that you need to update inside your animation blueprint, and then just manually override it. So it might become a bit more ugly, particularly over time, right? Like if you need these if statements effectively all over the place. But it's certainly more manageable than having two instances of an animation blueprint class, right? Because then you'd effectively duplicate your effort. And that's effectively it, I believe. So with all of this, you should be able to start synchronizing the motion for your characters inside Unreal Engine. So good luck. If you've got any questions, let me know. But yeah, see you around. Thanks, everyone.